Hello everyone. We are going to be going over factors and how to find them. The problem that we'll be working with is the number 54. We're going to list all the factors of 54. Now, what I'm going to do to start, and what I always try to do to start, is put in 1 through 10 at the very side. 1, 3, 4, 5, 6, 7, 8, and 9. Just to set these are possible factors of 54. I know 1 times 54. That is a factor. 2 and 54. A good thing to note is that if this number is even, then 2 will be a factor of 54. I can't exactly see how many times that will be, so in order to find that number out, we do the 54 divided by the 2. So here we go. I'm going to use my blue pen. 2 goes into 5 at least 2 times. 2 times 2 is 4. 5 minus 4 is 1. Bring down the 4 there. 2 goes into 14 7 times. There we go. Remainder of 0. And it is 2 and 27. Now, the rule of 3, and a good thing to note is that if both of these numbers add up into a multiple of 3, then 3 will be a factor of the number 54. 5 plus 4 is 9, so 3 will be a factor. So I'm going to go ahead and find out how many times there's 3. There's 54. Of course, I would have given myself a little bit more room there, so I'm just going to draw a little line there. Hopefully, I won't need to. But 3 goes into 5 one time. There's 3. There's 2. And then there's 4. 3 goes into 24. Sorry, misspoke. And I should have used a different marker. Now, if some of us have difficulty figuring out what that number is that goes into 24, we can always work with 3 times 10, and that'll give us 30. We can subtract 3 to get 27. Then we'll have 3 times 9. Subtract 3 again, and that'll be 3 times 8, and that'll give us the 24 that we need. So we know that 8 is going to be 18 times, and there it is. Now, is 4 a factor of 54? I don't know, so we have to just quickly look. And what we can do again is divide. So I'm going to go ahead and divide by the number 4. If it looks like I'm going to have a remainder, we can stop and just note that 4 will not be a factor. So here we go, 54 divided by 4, 1 time. 4 times 1 is 4, and 5 minus 4 is 1. 14 and 4, they don't evenly go into it because it goes 4, 8, 12. Because of that 12, and then 14 is only 2 clicks away, we need it to be 4 clicks away in order for it to work, to give us 16. So that will not be 1. So here we go. We just cross it off. We know 5 is not a factor of 54 because it ends in the number 4. In order for 5 to be a factor, it has to end in 0 or a 5. Now 6. In order for 6 to be a factor, 2 and 3 both need to be factors of 54, in which case they are. Now with 6, we can use the fact that 6 times 10 is 60, so 6 times 9 should be 54. There we go. Now, is 7 a factor? I don't believe so, just because 6 times 9 is so close to 54 that I believe when we get to 7 times 9, that's 63, and even then, this one goes into a different pathway than this one. So that will not be a factor of 54. Will 8 be a factor of 54? Well, it's very hard to tell, but because that 4 is not a factor of 54, I don't believe 8 will be a factor of 54. Will 9 be a factor of 54? Well, 9's already there, right there. So we can cross that one off. And we know that 10 will not be a factor of 54 just because, in order for 10 to be a factor, it has to end in 0, and this ends in a 4. So the factors for 54 is 154, 227, 318, 6, and 9. And those are all the factors of 54. Remember, in order to find factors, we can divide to find out if a number is a factor of the number, as well as use the associative property, which I will be going over next. So let me go ahead and flip this page over. Let's use the associative property, which allows us to multiply any numbers in any order as long as they associate with a certain number. As long as you multiply them, you'll still end up with that same number. So for example, we're going to work with the problem 38. Now we have to make this little tree here, and then we have to say what times what is 38. Now what I typically like to do is always go with the number 2 if it's even, and 38 is even, so there's 2. But then I have to figure out the number that goes here, so I usually just divide on the very side. 2 goes to 3 one time, there's 2, minus 3 minus 2 is 1, bring down the 8, that'll be 9, and then here we go, there we go, 19. Now I don't believe that 19 will have numbers that add up to it because 19 is a prime number, which means only 1 and 19 will multiply to get to 19. So because 19 is prime, I'm going to go ahead and circle in red all my prime numbers. There we go, and there we go. So we have the factors of 1, 38, 2, and 19. Now, because this was not a very great example, I did not know 38 was going to give us 19. I'm going to go ahead and do just one more using the same method. Hopefully I won't choose a number that, will give us a prime number there. Let's go ahead and choose 2 even numbers, because 2 even numbers would be really great for us. We're going to use the numbers 64, and then we're going to find numbers that multiply to 64. Now, once again, if you know multiplication tables, you can easily find a good set here. For some of us that have a little bit more difficulties, we can use 2 times half of 6, which is 3, and then half of 4, which is 2. Now we have 32. And then we just keep on riding that train. We can ride the 2's because look, there's still an even number. So 2 and half of 3, there's no really half of 3. So what I'm going to have to do is divide right over here. 2 goes in 3 one time, there's my 2. 3 minus 2 is 1, bring down my 12. 3 times 6 is 12. There we go, so 16. Now, I'm just going to keep on going. Now this time I'm going to use 4 times 4. Because that seems a little bit, a little bit easier, a little bit, doable. 2 times 2, and then 2 times 2. Then I'm going to go ahead and circle all of my prime numbers with my black pen. There's 1 prime, 2, 3, 4, 5, and 6. Now, we don't have any 3's, so 3 will not be a factor of 64. I'm going to write my factors in green. I'm going to write them right over here on the side. So 1 and 64. I know 2 and 32 right here. Those are going to be factors. And now what I can do is use the associative property. I'm going to do that in my blue pen. All I got to do is write down my 2's here. So I'm going to scoot my paper a little bit more forward. So 1, 2, 2 times 2 times 2 times 2 times 2 times 2. Now I can multiply all these 2's. 2 times 2 is 4. Times another 2 is 8. Times another 2 is 16. Then I can do 2 times 2, which is 4. So I know that 4 and 16 are factors of 64 because 4 times 16 will give us a 64. So now I'm going to rewrite these numbers again. Now I multiplied 1, 2, 3, 4 zeros together. Sorry, 4 2's together and then 2 2's together. Now I know if I did 16 times 2 again, I would have had 32 and 2, which is what we already have. So I'm going to try to avoid that as much as possible. So I have 1, 2, 3, 4, 5, 6 2's. 1, 2, 3, 4, 5, 6 2's. Now I'm going to do 4. 2 times 2 is 4. Times another 2 is 8. Then I'm going to stop there because I don't have an 8 yet here. And then I'm going to figure this out. 2 times 2 is 4. Times 2 is 8. So 8 times 8 is 64. And I believe these are the last of our factors for the number 64. So I have 1, 2, 3, 4, 5, 6, 7, 8 factors of 64. And that's one more way that you can figure out your factors by using the prime factorization method, where you keep breaking down that 64 and then circling your primes, and then use the associated property to multiply these twos in any order that you want in order to get the multiples of 64.